All right, answer is 12. Good, but we need to explore, again, just as a refresher, how we find GCF. Hopefully by this time, greatest common factor. Hopefully by this time, you're able to kind of look at them and have an idea of what their greatest common factor would be. Okay, first step, remember, we're going to start with any two factors that are going to give us what we're looking for here. So 2 and 2, 2 and 3, we go 6 times 6. When finding GCF, after we found the prime factorization, it's a good idea. I think it's a better idea to list them instead of using the exponents, just because it's easier for what we're going to do next. Listing them in order always helps. So after we take a look at the prime factorization for the 24 and for the 36, and I line them all up at the bottom, I will start circling what factors they have in common. They both have to have it in order for it to be in common. So they have a 2. They also have another 2. Anytime there's more than a common factor, I have to multiply them against each other. And then finally, they have a 3. Multiply it out. 2 and 2 is 4 times 3 gives us a GCF of 12, like we thought originally. Okay. Now, some of you found that out right away by looking at it, but you have to have a method that's going to work for you when you can't. Okay. 15. So 5 and 6. Okay. Sometimes the question is asked, do they have to be right on top of each other for them to have them in common? Well, let me ask you this. Is this a 3? Is that also a 3? Same number? Doesn't matter. Okay, so I have a 3. I got a 5. Yes, final answer is 15. They will also incorporate variables. For example, if I want the GCF of 12a squared and 16a to the third, numerically, between the 12 and the 16, what is their GCF? Four. 4 looks to be about right, okay? Because this has 8. That doesn't have 8. 6 doesn't work for this one. So yeah, I think that 4 is a good bet. Now, when you write out the variables, a times a times a times a, this gives us the a squared. That gives us a to the third. If I had these lined up right on top of each other, how many a's would they have in common? So the GCF of those two terms would be 4a squared. So you kind of treat them separately. The variables are somewhat easy to find out how many of them they would have in common. And since you've already done the integers, really shouldn't be all that new or difficult. Okay. $20x squared y and 16xy. GCF of 20 and 16. 4. GCF of x squared and x. And y squared. There it is. Yeah? Sure. Yes? Because how many x's do you have here? 2. How many do you have here? 1. So So you can't say they both have 2 in common. If they have both had 2 in common, they'd both have to have at least 2. If you line them up on top of each other, this one you'd have x times x. This one is just x. So you really only be circling one pair of x's. Okay? Now, the rest of the lesson goes through pretty much various cases that are going to be similar to this. We move on to 7-3, page 185. We're going to explore factoring using the distributive property in which we'll have to find the GCF. So let's jump there as part of our double. What is the distributive property, first of all? How can we use the distributive property to help us easily solve a problem like 4 times 63 in our heads, or do most of the work in our head? Remember this? Kind of? Mark? Yeah, very, very close. We're going to pull one of these numbers on the outside of a set of parentheses. Usually you pull the easier of the two that is to multiply. 4 is a lot easier to multiply with than 63. What we're going to do is break up the 63 and make it an addition problem within the set of parentheses. Looking at the digits, the 6 represents what? 60. And of course, the 3. So that's when I take a look and say, okay, 4 times 60 plus 4 times 3. 4 times 6, 24, with a 0 is 240, and 12 equals 52. Kind of remember all that a little bit, right? Okay, we've done that before. We've probably been doing that for a couple of years. We used to spend entire lessons on it. Now we can just use it as a tool. All right? Now, for today, we're going to take a look at expressions starting off as basic as something like this. A 3a plus a 9b. And we're going to start off by trying to find the GCF of both of these terms, of 3a and 9b. So numerically, the GCF between a 3 and a 9 is going to be 3. And do A and B have anything in common there with variables? So their GCF is 3. They don't have a variable in common, so we can't use that as a common factor. On the inside of the set of parentheses, I need to kind of go backwards and say, what do I need to multiply this 3 by to get 3a? Or just a? What do I need to multiply this 3 by to get 9b? Okay, 3b. We have just factored using the distributive property. How do you check it? Mark. Do the work. Go back and do the work. Is 3 times a 3a? And is 3 times 3b 9b? And the signs match up with positive and negative? Okay, good. Any questions? (7q minus 42p). Only thing majorly different here than the last one is the sign in the middle. And yes, that does make a difference. What is the GCF between a 7q and a 42p? Marlia. What do they have in common? 7. Good. The GCF. Don't get ahead of yourself, okay? Now, what do I need to multiply the 7 by to get a positive 7q? Just q. here. What do I need to multiply the 7 by to get a negative 42p? Negative 6p. Okay. Good? I'm just thrilled. Full of excitement. Give it a shot. All right, so Marlia, I think I've got an idea that you've got this. So what is a GCF of 9x squared plus 21x? 3x. Oh. 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 So now, 3x times what to give me 9x squared? Well, 3 times what gives us 9? And x times what gives me x squared? 3x. Then Mark. Because you're not pulling out the GCF. I mean, you either call something the greatest common factor or you don't. You don't pick and choose. There is only one greatest. It's not like a great common factor or like a greater. It's the greatest. There's only one. Plus what? That's it. Because later, Mark, to be honest with you, if you don't pull out the right GCF, there's going to come a time you're going to pull out you're going to find the GCF, and then what's left on the inside, you're going to have to factor as well. Like do the opposite of foiling, do the opposite of difference of squares, do the opposite of perfect squares. So you're going to have to go back, and if you don't pull it out right there, your parentheses are going to be all messed up, and you're not going to be able to factor it, and you're going to say, I wish I would have just gone with the greatest common factor. Does that answer your question? (21) 14 and 21. What is the GCF numerically, Raven? 7. 7xy. All right. So what are we going to multiply 7xy by to get 14xy? 2 plus what? 3y. You get it? Mark. All right, good. Got this. Yeah. Read a book. What do you? Yeah, I'm gonna let you play Uno in the middle of class. Okay, there you go. No. X and Y look good. Z needs a little something something. No, that's not it. Just don't erase it. You have 2 Z's and 3 Z's. How many Z's would you have in common? Good, so put a little 2 over there. There you go. All right. There we go. Not necessary, but not wrong.
Oh my god.
Not necessary, but not wrong. Keep. Not necessary, but not wrong. Keep going. Careful.
Okay, well, I thought you first this, so not all of it is
No, it's not all messed up. X times X still gives you X squared. Y times Y still gives you Y squared. Z squared times what gives you Z squared? You don't need that Z. All right, good. Keep it going. Good. Hey, good work. Got it. You don't need this one, but if you wanted to put it, it wouldn't be wrong. Yeah. Did I say that?
No, he didn't.
Did I say raise your hand? I thought you said Ms. Anyway, Ms.
Oh.
All right, let's see. If you can do number 57, you can do any of them.
Oh, I'm on the 86.
840, and numerically we're looking at a what? 8. Now, m squared, m, and m, just an m. N squared, n, and n squared, again another n. P squared, p squared, p squared. All right. So now, to get from 8 to 16 is a 2. I need another m and another n. So 2mn. Right?
No. Because, well,
What? We're good. Plus 8mnp squared, 8mnp squared. Marlia. 1. Watch, Marlia, Kate, listen. If I go back and check, and I don't put anything there, how am I going to get it? If I'm going to multiply this times nothing, what am I going to get? Nothing. But if I multiply the whole thing times 1, I will get this. Multiply anything times 1, you get what you started with, right? So it works the same way here. Yes, question? Yeah, it's still going to be... But you're missing the point again. You need the G, C, F. No, but Mark, it's all training. If you don't train yourself the right way, when you need to have it, you're not going to have it. And then you're really going to be upset about it. All right, then finally, an 8 to a negative 40 is a negative 5. I don't need any more M's. I do need an N. I don't need any more P's, and there you have it. Okay? But this here, yeah, but that there, I kind of expected was going to happen because we didn't have any examples of that in particular. But You know, if it comes up again.
Okay.